far away, on the outer edge of the solar system, where sunlight is nothing more than a faint blur, lies a dark blue, icy, and mysterious planet, Neptune. Neptune, the eighth planet, is a world that humans have never set foot on, yet its terrifying winds and strange atmosphere have fascinated scientists for centuries. It is the place of the fastest storms in the solar system, a world full of the unexplainable, a testament to the grandeur and strangeness of the universe. So, what exactly is Neptune? What lies inside that cold, distant planet? And is it hiding something humanity has never known? Now then, join me on a journey to Neptune, the edge of light, and the beginning of the untold. Science is the discipline that humans have pursued to understand and explore the world around them, aiming to expand the boundaries of knowledge. To achieve this, science must experiment with new things, reaching into the distant and beyond everyday comprehension to what lies in the unknown. But hypothesis, that is also the main purpose of science, to propose ideas that explain the world and then find ways to determine which hypothesis is the most accurate. For this reason, the hypotheses that are proven true become the cornerstones of science. When Einstein proposed his theory of how the universe works, scientists spent years calculating and testing until they finally concluded that he was right. From that point on, space science took great strides, helping humanity evolve further. However, that was not the only major advancement in the history of astronomy. One day, someone looked up at the sky, pointed to a distant void, and said, "What if there were a planet out there?" Since ancient times, when looking up at the sky, people could easily see giant objects floating in space. They named them the Sun, the Moon, and further out, Venus, Mercury, Jupiter, and Saturn. These were 6 objects in the sky that we could observe with the naked eye. The rest we called stars. At that time, the difference between planets and stars mainly came down to movement. If they moved over time, they were planets, meaning wandering stars. If they remained fixed in the sky, they were stars or celestial lights. However, by the 17th century with Galileo, everything began to change. Humanity's perspective on celestial bodies slowly evolved. At first, we only knew them as stars, those bright points in the sky, but gradually we came to understand that they are family. The journey to explore and understand the universe captured the attention of many brilliant minds, and from there we had Newton, born in the 17th century, not long after Galileo had his telescope. Newton was a brilliant mind with a genius intellect. Thanks to his imagination and natural calculating abilities, Newton changed the world when he published his discoveries about the laws of motion. Thanks to Newton's laws, astronomers gained a solid foundation to study and develop various hypotheses about the universe around them. Furthermore, Newton's laws laid the groundwork for what we now call gravity, something so miraculous that it causes matter to be drawn closer together. With Newton's formula for calculating gravitational force between objects with mass, scientists were able to determine the orbits, sizes, and basic properties of the planets surrounding Earth. This was undoubtedly a major turning point in the development of astronomy. However, at the time, it was still the early days of astronomical science. Humanity did not yet have a comprehensive view of the universe. Partly this was due to the limitations of technology, which could not yet support more detailed observations. The other reason was that no greater mind had yet emerged to fill the gaps in Newton's research. One typical example is that Newton never truly explained what gravity is. As great as he was the one who discovered gravity, not the one who could explain it. Although his formulas helped the field of astronomy advance significantly, they still had limitations that researchers had to accept. One of those limitations was the scope of the concept of gravity. In the 17th century, humanity still had a vague understanding of gravity. People still believed that gravity was a force, but it wasn't clear whether it was something unique to us or whether it existed elsewhere in the universe in the same way. Some scientists believed that gravity was something exclusive to our little corner of the sun, that it had limits, and that beyond a certain distance, Newton's laws would no longer apply. For this reason, the discovery of a new planet was quite strange at the time, not because people hadn't thought about the possibility of other planets out there, but because they believed that beyond Saturn, things would no longer follow Newton's laws and would instead possess entirely different characteristics. Then, in early March 1781, a German musician named William built himself an exceptionally refined telescope and looked up at the sky. At first it was merely a hobby he wanted to try out, but then he saw something a bit strange in the region of Taurus. Not thinking he had discovered a new planet, he assumed it was a comet and only dared to consider it a comet. But after years of research and calculations, William's comet turned out to be the discovery of a new planet astonished the entire astronomical community. Instead of thinking that there were no more planets out there, they now realized that there might be an entire ocean of planets waiting to be discovered. And while observing Uranus, they noticed something peculiar. At this point, it was well understood that planets are influenced dynamically by celestial bodies around them. Even Earth experiences slight wobbling when affected by the Sun and nearby celestial objects. So it made sense that Uranus would wobble a bit as it passed by Saturn and Jupiter. But sometimes it wobbled in places where there was nothing at all. The idea that Newton's laws only applied within certain boundaries was still widely held. Most believed that Newton's laws had certain limits, and beyond Jupiter's orbit, his laws would gradually become ineffective. But not everyone agreed with this view. By the 19th century, when Uranus was nearing the completion of one orbit around the Sun, mathematician John Couch Adams studied its trajectory and suspected that its wobbling was caused by the gravitational pull of another distant planet in the outer universe. That may sound simple now, but at the time it was something that had never been done before. Historically, humans had always used planetary motion and orbits to calculate the gravitational forces between them, but the problem John posed was completely the opposite. They would have to use the gravitational influences to calculate the orbit and position of an imagined planet. Still, they were determined to believe in Newton's laws and eagerly devoured the dreamlike numbers they had in front of them. By 1845, both men had produced results. Urbain Le Verrier, who was based in France, was luckier than his counterpart, as he successfully sent his research to another astronomer named Johann. Johann, a friend of Le Verrier, did not hesitate to point his telescope at the sky from the observatory in Berlin. To their surprise, the dream planet that Le Verrier had predicted was found almost exactly where he had calculated in his research. This newly discovered planet went down in astronomical history as the first planet found through mathematics and the laws of dynamics. From this point on, astronomers gained a new tool to observe the heavens. Previously, they only had information about planets' brightness, cycles, and orbits. Now they had mathematics and physical laws to rely on. This marked a great leap forward in astronomy because it became the foundation for future scientists to continue studying the sky, calculating based on known planets, inferring the existence of unseen planets, and using these dream planets to further predict other invisible ones. As technology began to catch up with human intellect, and telescopes were improved, the results were astonishing. Almost every calculation proved accurate. What had once only existed on paper was now right before their eyes. Seeing it firsthand was incomparable to just hearing about it. Indeed, This was a monumental awakening for humanity. After its discovery, the planet was colloquially called the planet beyond Uranus, or the planet Leverrier found. Naturally, no one wanted a newly discovered planet to have such a casual name. Once acknowledged as the discoverer, Leverrier quickly proposed naming the planet after the god of the sea. Naming planets after Roman gods had been a long-standing tradition in astronomy, so the name Neptune, the god of the sea, received wide acceptance among scientists of that time. As the last officially recognized planet, Neptune is incredibly far from Earth. The distance between Earth and the Sun is about 152 million kilometers, what we call 1 astronomical unit. Neptune's distance from the Sun is about 30 astronomical units, 30 times the Earth-spun distance, roughly 4.5 billion kilometers. Imagine the farthest distance you have ever traveled from Earth, then compare that to Neptune's distance from the Sun. At this distance, Neptune's orbit is so vast that it takes 165 Earth years to complete one revolution around the Sun, nearly twice as long as its nearest sister planet Uranus, which takes 84 years. Speaking of Uranus, Neptune shares many similarities with this planet. First, their masses are relatively comparable. Neptune is about 17 times more massive than Earth, with an equatorial radius of approximately 24,764 kilometers, 4 times that of Earth. Additionally, the properties of Uranus and Neptune are quite similar. Both are composed of water surrounding a superdense solid core. These planets are believed to have formed from frozen water that had sat into bonds along with many impurities, making up more than 40% of the planet's total mass. Given Neptune's size, its core is estimated to be about 1.5 times the size of Earth. Its mantle is primarily made of water, ammonia, and frozen methane. Finally, Neptune's atmosphere consists of hydrogen, helium, and methane gases. For this reason, Neptune is classified in the same category as Uranus, the ice giant planets, also known as the ice giants. Although Neptune differs greatly from Earth, it still shares some notable similarities with our planet. Its axial tilt is almost exactly the same as Earth's and Mars's, about 28 degrees, which causes Neptune to experience 4 seasons similar to ours. However, due to its enormous orbit, each season on Neptune lasts an incredible length of time. A single season there spans about 42 Earth years. These numbers might lead us to imagine Neptune as a slow, gentle planet, a massive ice ball drifting calmly through space. Yet the reality is quite the opposite. Neptune is a planet with a dizzyingly fast rotation. While 1 year on Neptune is more than 160 Earth years, a single day there is shorter than the waking hours of a human. A day on Neptune lasts only 16 Earth hours. Because of this rapid rotation, this distant planet experiences winds reaching speeds up to 1,900 km/h. These winds are 5 times stronger than the most powerful storms on Earth, and have a deadly characteristic: they arrive before we can hear them. Due to the extreme wind speeds exceeding the speed of sound, anyone standing on Neptune would be swept away by the wind before they even heard it coming. But this is a hypothetical scenario, as no one can actually stand on Neptune. Being classified among the gas giants, Neptune has no solid surface and is essentially a vast ocean. Nothing could stand on this planet. However, this is somewhat unfortunate, because if we could get there, we might be able to confirm an intriguing hypothesis about Neptune. According to this hypothesis, Neptune may experience unusual rain, diamond rain. The atmosphere of this giant gas planet is much denser than Earth's ocean floor, enough to freeze water instantly into an exotic metallic form. Under such pressure, carbon crystals in the atmosphere could easily form diamonds during these rains. But this remains just a hypothesis. We have no way to verify it until someone reaches Neptune and studies it in greater detail. So why don't we do that? Don't humans send satellites to study every planet? Indeed, we have sent a probe to Neptune, but only once in the history of astronomy. That was Voyager. In August 1977, Voyager 2 was launched into space to explore the distant planet. In 1981, it passed Saturn and used the giant planet's gravity to slingshot itself toward the next target, Uranus. There, Voyager 2 sent back invaluable data about this strange planet of the solar system. After completing that fascinating mission, Voyager 2's next destination was the 8th planet, Neptune. On August 25, 1989, Voyager 2 approached the most distant planet of the solar system. This mission was carefully planned so Voyager 2 would pass directly through the Neptune system and its largest moon, Triton. Thanks to this journey, Voyager 2 was able to fly past the icy planet and continue into the vast unknown of space, becoming one of the first spacecraft to leave the solar system. Although Voyager 2's flyby of Neptune was brief, the information it sent back has been invaluable to us. Neptune is the first planet ever predicted mathematically. For many years we could only see it as a tiny speck in the sky. After telescopes improved, that speck became easier to observe, but it still appeared only as a small white dot. The journey of Voyager 2 was the first time we witnessed firsthand the grandeur of the ice giant planet. The most prominent feature of this icy planet is a massive dark spot in its atmosphere. This dark spot is a raging storm on the planet's surface with a size comparable to Earth. Not only that, but this storm also moves across the planet at an incredible speed. Additionally, this storm has a smaller sister located in the southern hemisphere of the planet. However, these are not eternal storms like those on Jupiter and Saturn. After the Hubble telescope was launched into orbit and began observing the planet, these storms were no longer visible. Instead, new storms and cloud patterns appeared, proving that Neptune's weather is indeed very dynamic. Yet the climate of this planet remains strange. We know that storms occur due to convection, and for giant gas planets with atmospheres denser than Earth's, having storms is normal. However, a cold ice planet like Uranus would hardly have storms, so why does Neptune have such massive storms? When Hubble looked more closely using its infrared lens, a new discovery was made. It turned out that this ice giant is not as cold as we once thought. Despite being the farthest planet in the solar system, Neptune is not the coldest. That title belongs to its sister, Uranus. But why is that? Being the farthest, receiving the least sunlight, Neptune should be the coldest, right? What causes the difference between these twin planets? The answer likely does not lie with Neptune, but with Uranus. According to astronomers, one way to explain Uranus's sideways tilt is that, in the distant past, a planet the size of Earth collided with Uranus, causing the planet to tilt so dramatically. This collision not only made Uranus lie down, but also caused it to lose much of its internal heat production. So if it weren't for that collision, Uranus might have been like Neptune, a spinning ice giant with stable heat emission. However, this remains a hypothesis. We have no time machine to go back and confirm it, or at least not until Voyager and its sister probes send us more information from the vast universe, helping us understand other planets like Uranus and Neptune and the collisions that shaped them, from which we can deduce the official reason. So, is that all? Did Voyager 2 just fly by and bring back images of two storms and a few scant details? Actually, we discovered many other interesting things, but most of the information was used by astronomers to plan more efficient missions in the future. That doesn't mean we've run out of stories about this distant planet. Surprisingly, Neptune isn't too different from the three giant gas planets before it. In the past, when we looked up at the sky and saw only a tiny white dot, it was hard to say what made this planet special. But when Voyager 2 focused its lens on it, we had to marvel at the fact that this little bright spot has a magnificent ring system, rivaling that of Uranus. Neptune has between 5 and 6 rings around it. These rings are thin and faint, with bright arcs created by the planet's small moons. The rings bear poetic names: Gall, Leverrier, Lassell, Arago, and Adams, named after those who contributed to discovering this planet, from mathematicians to astronomers at the Berlin Observatory. Moreover, the bright arcs within the rings are named Liberty, Equality, Fraternity, and Courage, meaning freedom, justice, friendship, and bravery. That's poetry. But these rings are almost invisible through telescopes because they are too thin to reflect much sunlight, and at such a great distance they are lost in the vast darkness of space. Still, these rings remain a beautiful part of creation that humanity has witnessed in its short history, and that was the story of Neptune, the last planet of the solar system. What do you think about this planet? Share your thoughts and questions below. Also, if you enjoy this kind of content, don't forget the universe is vast and infinite. Stories about it will continue, and we will keep sharing about planets and stars in the future. So, don't forget to hit like and subscribe to the channel. Thank you all for listening. See you next time.